All right, today we're going to talk about systems of quadratic equations. So let's do a quick review on systems. So remember, a solution is wherever your functions or wherever your equations intersect. So for number one way to find a solution is through graphing. So just a quick review of y equals mx plus b. So this is your y-intercept, which would be 1 here. And this says you're going to go up 2 and you're going to go to the right 1. So from your y-intercept of 1, we're going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And usually I'll repeat the pattern going the other way until I complete the graph. So, but right now, I can already see a spot. Now I'm going to go ahead and I'm going to graph this. So we're going to start at positive 6, which is right here. And this is telling us we're going to go down 3 and to the right 1. So down 3 to the right 1. Or you can go up 3 and to the left 1. So I'm starting at 6 and I'm going to go 1, 2, 3 to the right 1. I intersected there, but I'm just going to keep going to the right 1. To the right, and continue my pattern. Now, if you notice, I already intersected at this point right here. So this point where the two intersect, that is called your solution. So in this case, your solution would be 1, oops, I didn't mean to make that so fluffy. There you go. 1, 3, that's your solution. So that's one way is through graphing. Another way to do this is algebraically. So remember, you could do substitution, elimination. You've done a bunch of different ways of graphing. So you've had lots of practice with this. So in this case, I think substitution would be the best choice because they're both equal to y. So then you can just equal these guys to each other. And you're going to move the variables over to this side and move all the numbers to that side. So that's why I added 3x. And then I'm going to move the constant over here. That cancels. And I've got 5x over 5. And then that cancels. And I've got 5 here. So divide both sides by 5. And you'll get x equals 1. So now that we know x equals 1, we're going to substitute this into our original either equation. And then you're going to go 2 times 1. You could have put it in here also. We still would have gotten the same thing because it's a solution for both lines. And then once you substitute that in and you solve it, you'll see y equals 3. So you're going to take your 1 and your 3, so your x and your y. And that's your solution. So we can solve the same thing doing it 2 different ways. So in this case, solve the system graphically. So I showed you algebraically, but let me show you graphically here. So for this, it says, let's see, I'll do pink. That's what I had. Okay, there we go. So for this one, we need to figure out where the vertex is. So we can go x equals negative b over 2a, and that tells you x equals 4 over 2, x equals 2. So now that we know x equals 2, now we can plug it in to our equations, and it will go 2 squared minus 4 times 2 plus 6, and then we'll get 4 minus 8 plus 6, that equals 2. So this is our y and our x. So we know that at 2, 2, this is going to be our vertex for the parabola. So we're going to go over here and we're going to graph 2, 2. And then now you can go ahead and you can plug in your points. You can do the 1a, 3a, 5a. I'm going to go, since there's a 1 and over, then over 1 up 3, over 1 up 3. And then if you did this correctly, it should look like that. All right, now for my other line, I've got g of x equals 3. Well, this would be that all of your y values or all your g values would be 3. So then I'm going to go ahead, that means this line right here, because it should be a horizontal line. All right, and then now we just need to look, where did they intersect? Well, they intersected here, oops. They intersected here, and they intersected here. So that means that your solutions, or the answers to this, is 1, 3 and 3, 3. Because that's where they intersect. Okay, so now let's go ahead and let's look over here at the equation. So now we're going to do the same thing we did before, where I'm going to take, since these are both equal to that, I'm just going to take this and equal it to 3. So that equals 3, set it up, moved 3 over, so now I have this, so I can solve it. I broke up -4 into -1, -3. Go ahead, group them. And now I've got x and -3 makes this, and then x minus 1 makes this. So you're going to set them each equal to 0, but like I said, once you start to get the pattern and you just realize, oh, 3, 3, and then opposite sign goes here, then you should know x equals 3, x equals 1. Now that we know x equals 3 and x equals 1, now we can go ahead and we can plug this into here and into here wherever you see x. And then we got 3, so simplified. And then we're also going to take this x, because there's 2 x's, and we're going to plug it into here, and we're going to plug it into here and simplify, and you'll also get 3 for that one. Now, it also makes sense, because didn't we just say that the y value is going to be 3? So substitute it in this case it was easy because I already told you the y value. And then you go ahead, you put it together, and if you notice, we got the same thing here that we did there. It's just different ways of solving them. For this one, you can skip because it has inequalities. We're not going to do inequalities right now, so go ahead, skip this one. And then what you're going to do on this one is you can log into Desmos, and you can actually use this, and I'll show you what I did for the first one. All right, so for this, there it goes. I typed in both of the equations. So I have x squared minus 4x minus 2, and remember, to add an equation, you can just go here to the plus sign in the top left corner, and you can do your expression, and then you can type in whatever you want. I don't need that because I already typed these in. All right, so I did f of x equals x squared minus 4x minus 2. And if you notice, this is red right next to the equation. So that would be the red parabola, or the red graph. And then for number 2, it's blue, and it's g of x equals negative 6x minus 3. So if you notice, that is the blue graph on Desmos. So now remember, you have to figure out where do they intersect. So sometimes you might need to zoom in a little to figure out. Let's see. Yep, it looks like there they intersect, and let's see what point that is. It's -1, 3. So that would be your intercept, because that is a point. Now it looks like it's kind of intersecting here, but if you keep zooming in, they're very, very close, but not quite. So 1, 3. This would tell you the 0 for that, but if as soon as you click the line, it's going to tell you where your y-intercept is. So now you come back here, oops, and after using that, you know your intercept is at -1, 3, and that's your answer. So what you're going to do is you can use Desmos on this. So again, this is Desmos. So you're going to enter in these equations on Desmos, and you're going to figure out where your solutions are. And hint, you're going to have 2 solutions because these are both quadratic. So they're going to intersect hopefully a couple times. So be on the lookout for that. And then that is how you do systems of quadratic equations.